Welcome all of you. We will start the topic about magnetic particle testing, fifth topic in the types of NDT. This is a free certified YouTube course. Subscribe the channel for updates on new topics.
We will start with what is magnetic particle testing. It is a procedure used to check for deficiencies, such as cracks by spreading a thin liquid dye onto the material's surface, followed by the application of a developer. You will see the different names for magnetic particle testing. MPI magnetic particle inspection. What is a handheld MPI device called? Magnetic yoke is a handheld device that induces a magnetic field between two poles. When was it discovered and by whom? Discovered by William Hooke. During 1930s. Reason to develop magnetic particle testing. As a way to check steel components on production lines. In this slide you will be seeing some of the uses of MPT. To find subsurface flaws in most ferromagnetic materials such iron, nickel, cobalt, and some of their alloys. Advantages. Immediate indications, objects can be examined, uncomplicated, surface and near-surface defects. Disadvantages. It is messy, cannot be used if a thick paint coating is present, interpretation is a skilled task, need a supply of electricity. You will know about some of the new innovations. Innovations were done in the coil for more reliable outputs. It was difficult to be used in confined space. New innovations are in progress to ease of the process. Next you will see a video for live visualization of complete process.
Magnetic testing is a fast and accurate method to indicate irregularities located at or closely under the surface. The method only works on magnetic materials. Paint layers or rust can affect the examination negatively, so it is important to first clean the surface carefully. A yoke magnet generates a magnetic field between two poles. On the Berthold penetrometer, one can see the direction in which the magnetic field is moving. We call this the magnetic flux. In other words, we examine whether the natural direction of the magnetic field is interrupted. If that is the case, we have what we call an indication of an irregularity or a leak field. We prove this by spraying tiny iron particles on the object between the poles of the magnet. If a leak field is present, the particles will cluster together at the magnetic flux leakage. To make sure the buildup of the iron particles is clearly visible, in some cases the surface is first sprayed with a thin layer of contrast paint. The examiner carefully checks that he didn't miss anything. He then applies a magnetic field crosswise over the surface. Then he sprays a black suspension powder, a liquid in which small iron particles are suspended that react to the magnetic field. The examiner watches the iron particles' reaction carefully. Then the MT examination is done in the 90-degree direction to ensure 100% coverage. In this case, the weld did not indicate a leak field. The examiner indicates that the result is acceptable.
What new methods and for which type of industries do you think it can be developed? Write in the comments below. Steps to complete course. Watch complete series. Answer few questions on Telegram. Message in group in the format given below. Next video in this series will be about types of IR thermograph test. Next video link will be in the description below. Subscribe the channel for updates on new video of the series. Thank you from Team Hipstema.